Hey guys, this is Harold L.R. Watkins back with another video. In this video, I'm going to show my AutoSec Local AI. This is a Python desktop application for private automotive diagnostics and cybersecurity analysis. Just give me a moment while I run it. Okay. It runs a GGUF language model locally through Llama and combines the model with trusted UDS knowledge, deterministic decoding, and accuracy guardrails. I'm gonna grab the llama here. And before I get in here, I'm just gonna show you the format of my code structure. Okay. The program is split into a few files, each with one job. The way a car has separate systems for the engine, the brakes, and the dashboard, main pie is like the dashboard, which you see here. Um, yes, it's like the dashboard, basically what you see on the screen. Um, LLM service.py, which you see here, is the part that talks to the AI model. UDS decoder and UDS knowledge.py is the fact checker. It decides when to trust the reference book instead of the AI, and it double checks the AI answers before showing it. That way, the facts that um, must always be right never depend on the AI guessing. Going back to the GUI, I'm going to enter a sentence and click analyze locally. This open-ended question does not match a deterministic template, so the loaded GGUF model generates the response on this computer. And you're going to see the timing down here so you know that it's running. So it took 25.4 seconds, and then 27 words. Okay. The interface remains responsive because uh, the inference runs in the background. The local LLM metrics proves this was model generated, not a template. Before the display, the accuracy layer checks the answer for unsupported UDS, bytes, namespace confusion, and leaked internal instructions. Let's put in another question. This will validate that the UDS, the workflow for the UDS. For a known service, the app retrieves the reviewed read data by identifier definition and returns a deterministic validated answer. ECU specific DIDs and access rules still require the approved ECU specification. The next question, I'm going to run a few questions here. Single NRC questions use the same protected route. NRC base 35 is correctly identified as invalid key, separate from the service identifier namespace. Now we're going to select the decode 7F2735 and hit analyze locally. For raw traffic, Python identifies 7F as a negative response, 27 as a security access, and 35 as invalid key. This path is faster and more consistent than token by token generation because uh, exact protocol facts come from direct lookups, not predictions. Let's enter another question. The control comparison keeps identifiers in context. Service base 10 is diagnostic session control, which changes the diagnostic session. Service 27 or service base 27 is security access, which authorizes protective function. NRC base 10 means general reject only when it appears in the NRC field of a negative response. I'm just going to type 32. This is going to say ambiguous, which it does. 32 by itself is ambiguous. And then it asks you, do you mean UDS service 32, NRC 32? Um, so a bare value such as 32 is ambiguous. So the app asks for clarification instead of guessing. Um, export, and I want to run the export. We're going to end up putting this. And let's put this here. We can put it in downloads for now. And then I can open it up from downloads over here. And grab it from over here. Okay. So export preserves the session and clear recess the workspace. Input, model, inference, and file errors are handled without closing the application. Just gonna come off of here, and then we're gonna run. Let's close this, and then we're gonna run the Python unit test script discovery. Okay, so the final build has 43 passing tests covering decoding, trusted retrieval, service, and NRC definitions, ambiguity handling, namespace separation, response routing, and guardrail behavior. Then returning back to the app. AutoSec Local AI demonstrates a practical hybrid design. The local LLM provides flexible um, natural language assistance, while deterministic Python establishes protocol truth where accuracy matters. Trusted retrieval and guardrails add control while final engineering decisions remain tied to ECU specification and captured evidence. Thank you for watching.